We can put, if these are 15, we can put 5 rebars in one layer. So it will result how many number of bars? Number of layers? 3. Yeah. This is what I was saying. And this is what we have assumed. I don't have my reinforced concrete design 1 book with me, but this formula is there. And I'm not sure about this number or this number. Well, we can decide, we can provide the 5 number 25 in one layer. For example, if this is the girder, so we will provide 1, 2, 3, 4 and 5. Yes. 5 into 125, how much is this? 125? Yeah. So this is the main steel of the girder. This is the main steel. But you know, your girder is very deep. Very deep girder. This drawing is not on scale, so don't confuse. Okay? This drawing is not on scale. Your girder is actually 1.2 meter, very deep, and the steel is at the bottom. It means there is nothing on this side. Do you understand?
Yeah.
So what we do for deep girders, we provide the steel on the sides, and this steel is known as skin reinforcement. This steel is known as skin. Like this, skin. Skin reinforcement stirrups. For the stirrups and to control the shrinkage. If you don't provide any steel here, there could be shrinkage. Do you understand? So how much is this steel? We can get this steel straight away from a formula given by Ashbrook. And this steel is, the formula for this steel is 0.001 skin reinforcement 0.001 into D minus 760. Multiplied by this is multiplied by the height of the girder. And it should be less than this value. Or you can multiply h later on. So what is the answer? Please check this. AS is how much? This one?
Why? Just we forget to multiply by 1,200 or it's okay.
Don't multiply by anything, just use this equation. We will multiply h later on.
You get 0.3325.
This one?
Yes.
3325. And what is this? Is it less than this value? Yes, I think. Yeah, it is. 6 point something, I don't know. So it's fine. So what is this? This is actually
6.3.
millimeter square per millimeter height of the girder. To get the total steel, you should multiply by the height of the girder. And the height of the girder is how much? Okay, what is the answer?
Answer 415.6.
How much?
415.6.
If how much? 4,000?
No, 415. 415.6.
Millimeter square per meter height of the girder. So this is the steel which you have to provide on all these sides. It is very less. Maybe if you use number 13 or number 10. Number 10, how many number of bars you need? If I use number 10, so the area of number 10 rebar is
71.
how many number of bars? 4, 5, 6. 6. So put like 3 bars on this side and 3 bars on the other side. Okay? Put 3 bars on this side and 3 bars on the other side. At the top we will be having the hanger bars, and these hanger bars you can use like 5 number 10 or 5 number 13. Why we provide these bars? To hold the stirrups. If it is a singly reinforced beam, we provide the hanger bars at the top to hold the stirrups. These bars have to do nothing with the design but just to hold the stirrups. We have designed our girder, flexural. Now shear. This is the flexural design, and now we will move to the shear. Do you have any question?
Which size you said that we have to above the top?
Use minimum number 10. Minimum. But the good size is number 13. If you are using number 25, use number 13. Okay? Number 13 bar. Okay, let's go next. I will make the whole sketch later on, but just keep all these values in your mind. And now I'm going to move for the shear. Shear design is very simple. 15 number 25, and then the skin reinforcement we decided 6 number 10. Yes, 6 number 10 skin. And this is the main. Now let's check the shear strength. Shear design. It's very simple. How much is BU? 8 something. BU.
887.
880. Kilonewton. Okay. So before we proceed further, we have to calculate dV. You know, the shear strength, the nominal shear strength, of Bn, the nominal shear strength, is equal to 5VC plus 5VS. This is the contribution of the concrete, and this is the contribution of the steel. So this we can calculate 5VC is lesser of Number 1, 0.166 square root FC prime B W D B. BW or DB. So what is DV? DV is larger of three things. We also calculated this for the slab. DV is larger of number 1 0.9 DE, 0.9 into D effective depth, Zero 0.72 into H, and D minus A over 2. So it's very simple. This you can check 0.9 into D. D is actually the depth of the concrete, the total depth. You can take it to be on the safer side. Let's take it 0.85. I'm going a little bit safer than the code. D
1000.
How much was A? 56 over 2. Nine hundred
28.
28. Which one? This one?
The first one.
And this one?
$900.
900.
Yeah.
And third one? I think this will go on. D minus A over 2.
1064.
So DV is, now you can calculate 5VBC is 0.166 FC prime into BW into DV divided by 1000 to get in kilonewton.
For 170.
How much?
470.
470. So it means that out of 887, 470 will be taken by the concrete, and the remaining 400 it will go to the steel. So there's a formula to calculate the steel reinforcement. There's a formula S maximum. S is equal to ABFY into D V over phi VU minus phi V VC. We did not multiply by the phi factor. The phi factor, I'm sorry, is 0.9. I'm sorry, I did not multiply by the phi factor. So multiply this by 0.9.
443.
So BU phi will be
The factor is different from ACI.
yes. ACI is 0.75. This is the astro. Astro is 0.9. So you can calculate S. Now, AB is the area of bar in shear. It depends upon you which bar diameter you want to use. Number 10, 13, it depends upon you. If you use bigger bar,
The space will be
Space will increase.
the spacing will increase. It means the steel will be very far. But if you use smaller bar diameter, the spacing will be.
decreased.
So what do you want to assume? Let's check number 13.
Okay.
AB is equal to 2 times the area of rebar. This is AB. Because your stirrup is like this, so area of rebar comes 2 times. Into Fy into dV Bu minus 4 to 3. To convert into Newton, multiply by 1000, you will get S in millimeters. But can you start your attendance from right side on one paper?
248.
248.
Yes, 45.
Say S is equal to 225 mm. So it means you should provide number 13 at the rate of center to center. So we have designed our beam. We have done. This is the shear reinforcement, number 13 bar after every 225. Just round it to the lowest 25 mm. For example, the lowest 25 mm rounding of 248 is 2 to 5. So now we are ready to draw the cross section of the bridge. Let's draw it and enjoy. This skin reinforcement, there is also one S, and that S is D by 6. I mean, the spacing should be less than this. How much is D by 6? Can you check? D is 109.
182.
Say 180. This is the S maximum for this number 10. I will tell you what is this now. So let me show the cross section of the bridge girder. You want me to show on scale? It's very difficult. Okay. So we have first of all, 3 layers of steel. 1, let me first draw the shear reinforcement. This will be the
Still.
stirrups. And then one bar. 1, 2, 3, 4, and 5. And then we will put a spacer bar to give a space of 25 mm. Second layer. Third layer.
The space. This. The
Yeah,
bar.
there is a spacer bar. We put, this is a longitudinal steel, we put a spacer bar like this. Okay? This is a spacer bar. And then the skin reinforcement, you can say the distance between the two number 10 bars should not be more than 180 mm. Do you understand? So you can say, you can show here the skin reinforcement, something like this.
So the 3 bars.
Yeah, it should be 3 bar, but if you provide the 3 bars, so what will happen? The spacing will become more. For example, if this distance, is 900, so it means 1 bar after 300. But the code says the bar spacing should not be more than 180. So we provide at 180. You understand? So we provide the skin reinforcement at 180, and then we should have 2 hanger bars at the top, or at least 3. Provide 3 or 5, whatever you like. So these are the hanger bars, 3 number 13. This is the main steel. 5 plus 5 plus 5, number 25. And this one is the shear steel, number 13 at the rate of 2 to 5. Any other steel, skin reinforcement. The skin reinforcement, this one, number 10 at the rate of 180. Number 10 after every 180. Just write it like this. Don't calculate. How much is this depth? 200. How much is this width?
450.
And how much is this total depth?
1,250.
So this concludes the design of your bridge girder. Okay, this is how your girder will look like. From where we started, from the bridge layout. You remember?
Yeah.
The layout. How many number of lanes, how many number of girders, how much would be the overhang, and where we ended up. So in all this journey, you have learned so many things. Number 1, how to decide the layout of the bridge girder, how to calculate number of lanes, how to design the slab, how to do the longitudinal and the transverse distribution of the loads, how to design the bridge girder, how to detail the bridge girder. This is all what we have learned. So this concludes this class, and thank you for your time and patience.
This is